food, you do it? You have that?
Yeah.
Okay, that's good. You don't need to eat. So you have no food in the mouth, but you taste food, right? You taste different tastes. Okay, so that is Phantoglycia. Dysgeusia. Distorted taste. Abnormal taste. You eat something, but you taste something different. Like you are eating banana, you are tasting, mango or something. So that is distorted taste. Dysgeusia. So those are few, clinical conditions that can happen due to change in the receptors, the number of receptors, or the nerve fibers. So that's the olfactory. Now the last thing, auditory system. Peripheral organs for auditory system are what? How many? Two. Okay. That's good. You were listening. 2 years. Okay. So only a small part of your ear you see from outside. That is called the pinna, right? You see a small part. Most part of ear is inside, you don't see. So ear has three parts: external or outer ear, middle ear, internal ear. Only a part of external ear you can see from outside. You see the pinna and part of acoustic meatus, that canal, outer ear canal is called external acoustic meatus. So you can see part of it. Then in the inner part of external ear, you have a membrane that is called tympanic membrane or eardrum, commonly known as what? Eardrum. Have you heard that?
Yep.
Eardrum. So that is the tympanic membrane. You don't see that. So you see only a part of external ear you can see from outside. Then you have middle ear. Middle ear is a cavity where inside the temporal bone, this is the temporal bone here. So inside the temporal bone you have a cavity, that is the middle ear. Middle ear. So basically this is the pinna, this is the external acoustic meatus, the canal, and this is the tympanic membrane or eardrum, and then this is the cavity, middle ear. Okay, inside the temporal bone. So this part is the external ear, pinna, external acoustic meatus, and tympanic membrane or eardrum. Tympanic membrane or eardrum, and then you have the middle ear cavity inside the temporal bone. Now inside the middle ear cavity you have three ossicles. Ossicles are tiny bones. How many? Three. The first one is attached to the other side of the tympanic membrane, that is called the malleus. The second one is the incus, and the third one is called the steps. So this is malleus, this is incus, this is steps. Three ossicles or tiny bones, and they are attached to each other. So like this, you see, three ossicles. This is one, this is middle one, and this is another. These three ossicles are attached to each other, and they can move like this. The joints are like this. They can easily move. Make sense? Like this. These three ossicles are attached to the bone by the muscles, tiny muscles. Those muscles, you need to know the name of those muscles. Tensor tympani and stapedius. S-T-A-P-D-U-S. We'll check it. Just know that three ossicles and two muscles in the middle ear. Three ossicles, tiny bones, and two tiny muscles. Okay, in the middle ear. Then the last part is inner ear. In the inner ear, you have a very important structure that is called the cochlea. Cochlea. Okay. Cochlea is a coiled tube-like structure. It looks like a snail filled with fluid. So inside the cochlea you have fluid. So in one sentence I will say cochlea is a snail-shaped, fluid-filled, coiled structure. Snail-shaped, fluid-filled, coiled structure located in the inner ear. So this part is the inner ear. Now what happens is, see, the end of this step is attached to the cochlea here, and this is called the oval window. It is oval shaped membrane here, that is called oval window. Okay, so now I am repeating again. This part is the external or outer ear, this part is the middle ear, and this part is the inner ear. Okay, three parts of the ear. Make sense? Okay, I am quickly repeating. So, external or outer ear, can you see the whole thing or part of it? Part. Which part you see? And the beginning of the acoustic meatus, right? The canal. Then, in the inner side, you have a membrane, right? That is called tympanic membrane, commonly known as eardrum. Make sense? And then you have what? Which part? The middle part, right? Middle ear, which is located inside what? Which bone? Temporal bone, right? A cavity inside the temporal bone. And that cavity contains how many tiny bones? Three. Those are called what? Ossicles, right? Three ossicles or tiny bones. Malleus, incus, step. And they are what? Separated or attached to each other? And they can vibrate, move, right? Shake like this. Is it clear? Okay. Then you have two tiny muscles, tensor tympani and stapedius. They are holding the ossicles in right locations, right? You need to tie or hold the ossicles. So you have two muscles. Now, the inner ear, a coiled snail-shaped fluid-filled structure is there. That is called what? Very important, right? You know, all of you know that. Cochlear implantation, right? We do. If cochlea is destroyed, we need to, use the artificial cochlea. Without cochlea, you won't hear the sound. Okay? So cochlea is very important. Now, you see what happens. Sound is actually waves in the air, and the sound waves enter into the ear, captured by the pinna then funneled into the acoustic meatus. And then the waves come like what? One after another, right? Waves come one after another and hit the tympanic membrane like this. Make sense? Very high frequency. And tympanic membrane does what? Vibrates. And when the tympanic membrane vibrates, you see here, malleus is attached to the tympanic membrane, right? The first ossicle. So, what will happen? This is the tympanic membrane and you have the ossicles in the other side. So, when the tympanic membrane shakes or vibrates, these three ossicles also vibrate. Make sense? And that is very important. Why? That vibration of those three ossicles intensifies the pressure of sound. Amplifies. Amplifies what? Sound pressure. Many times. So, have you seen lever to pull the heavy things? Lever? Lever, or is a lever? Or lever, okay. Whatever, lever, okay. That pulls the heavy thing, right? When you make the big buildings, you use that. So, the ossicles are like that, okay? So, that increases the power. Okay, now you see what happens. The last ossicle is attached to the oval window here. So oval window is a membrane, so that also shakes like this. Make sense? Vibrates like this. And in the other side of oval window you have what? Air or fluid? Fluid in the cochlea, right? You know that. So that movement of the oval window will move the fluid to the other side. Make sense? Now you tell me, to move the air you need more pressure, or to move the fluid you need more pressure? Fluid. You need more pressure to move the fluid, right? To move the air you don't need really much pressure. So that's why you need to amplify the sound pressure here, because the pressure is hitting the tympanic membrane here may not be enough to move the fluid. So the pressure is amplified many times by the ossicles here. And when it arrives here, that pressure is many times more, so that you will be able to move the fluid inside the cochlea. Make sense? That's why you need the amplification. Now if those three ossicles don't move, that can happen. You know, the joints, sometimes they get fixed. Some calcification occurs, you know. Calcium accumulates and forms like, you know, bone-like structure. So the joints get fixed. So will not move. So sound pressure will not be amplified. Make sense? So the person will not listen low pressure sound. Only very high. If you are very loud, the person will listen. Okay? So that will significantly, right, make your ability low to listen the sound. Okay? So that's why very important, those three ossicles. Okay. Now the last thing is the cochlea. This is the most important structure of your ear, cochlea. Why? Because the receptor cells are inside the cochlea. You already know by now that receptor cells are very important, right? So this is the cochlea. It is coiled, so if I make it straight, I can do that. I can cut this cochlea, put on a petri dish in the lab, like this, and make it straight. So it's like a coiled tongue. I can pull it, make it straight, okay? And now if I see inside the cochlea, there are two membranes. So three cavities inside, because there are two membranes. The upper one is called the vestibular membrane, and the lower one is called the basilar membrane. So remember, inside the cochlea is separated by two membranes into how many cavities?
2, 3.
Okay. Tell me, if I put two walls here, how many rooms you will get? 3. Make sense? So there are two membranes, 3 cavities. Now if I just take a slice, cut it and make a slice, take this part out and see under the microscope, you can easily do that. So just I'm taking a slice of this cochlea here, so it is like this. This is the vestibular membrane, this is the basilar membrane, and all these 3 are filled with fluid. Now, this basilar membrane is very important. Why? Because on the basilar membrane you have a structure that is called cortical organ. Cortical organ, or organ of Corti, also called a spiral organ. Same thing, okay? Okay. Why this is very important? Because the hair receptor cells, that is the sound receptor cells, are located here. The receptor cells are located inside the organ of Corti. There are 2 types of receptor cells. Outer hair cells and inner hair cells. Why they are called hair cells? Because they have hair on the top. Hair on the top like this. Okay. Now you tell me, if I ask you, cochlea is located in which part of the ear? Outer, middle, or inner? Inner. It looks like what? A snail, right?
Yep.
Coiled tube filled with what?
Fluid.
Fluid. Very good. Fluid filled, coil shaped, snail-like structure in the inner ear. Now you tell me, inside the cochlea, how many membranes? 2. Very good. 2 membranes, right? Upper one is called the vestibular membrane, lower one is called the basilar membrane. So how many chambers? 3. This is called scala vestibuli, scala media, scala tympani. Middle one is called the scala media. And above the vestibular membrane, scala vestibule. So if you just connect, it will be easy. Now you tell me, on the basilar membrane, you have a very important structure, I said. The name is cortical organ, a spiral organ. Is it clear? Why this is important? Because inside the cortical organ, you have the receptor cells. Is it clear? Called the hair cells. How many types of hair cells? Outer and? Very good. Why they are called hair cells? Because they have hair. So this is the hair cell, these are hair. Is it clear? Okay. Now you see what happens. A soft jelly-like membrane lies on the organ of Corti. This is called tectorial membrane. Tectorial membrane. So this is another membrane. It is soft like jelly. Now you see what happens. This is the hair cell and this is the tectorial membrane. And it is soft. So what happens? The hair are inserted into the tectorial membrane. Makes sense, right? Because it is soft. Is it clear? Okay. So now look at this, everybody. So these are what? Here. Then this is the tectorial soft jelly-like membrane. Makes sense? So the hair get inserted into it. Is that clear? Now let's go back. I said that oval window shakes, right? When ossicles shake, oval window also shakes like this. So that moves the fluid, right? Moves the fluid. So when the fluid moves here, fluid is everywhere. So when the fluid moves like this, what happens? This is intestine. The fluid is moving here like this. So the basilar membrane will move up and down. Make sense? Because the fluid is moving. So when the fluid moves up like this, the hair bend because of pressure. You are putting pressure from the bottom. Make sense? That will activate the hair cells. And then next, what will happen? Again, straight. Again, because waves coming one after another. Make sense? So bending the hair, activating the cell. Straightening the hair, deactivating. Okay? Inactivating the cells. So again, activating and deactivating. Make sense? Every time you activate the cell, signal goes to the brain. So if you have 500 times the wave in 1 second, 500 times it will happen. Make sense? If the sound wave is 2000 frequency, 2000 times, it will happen in 1 second. Just think that, how fast. Most like sending signal to the brain, 2000 times. Okay, that will give you 2000 hertz frequency sound. If 20,000 times, that also happens. That's the maximum we can hear, 20,000 times in 1 second. Can you believe? That many times your brain is getting signal from the hair cells. And you will perceive 20 kilohertz, that means 20,000 hertz sound, frequency sound. So that's different frequency of sound is perceived in the brain. Make sense? Okay. Now, that's how the auditory system works. I'll ask questions from everything I have explained here. Very important, okay? So if you know these things, I know you understood, but the thing is memorizing, right? Remembering, you have to practice. Okay? The last thing, hearing loss. Two types of hearing loss we know. One is called sensory neural loss. Another is called conductive loss. Okay, these are two types of hearing loss. Now if I put a cordon in your ear, you won't hear, right? So that is what? Conductive or sensory neural? What do you think? Conductive, because sound waves are not getting in. Make sense? If infection occurs, fluid accumulates, that is also conductive. Make sense? Fluid will block the sound waves. If a tumor is formed, that is also conductive. Sometimes dirt particles accumulate, right? That wax and dirt together block the ear. That is also conductive hearing loss. Make sense? The sound waves are not getting in. Easy or difficult to fix?
Easy.
Easy to fix, right? Easy to fix. Now, sensory neural hearing loss is very difficult to fix because this is the loss of hair cells in the organ of Corti, in the cochlea. If the hair cells are destroyed or die, is it easy to fix or difficult? Because hair cells, you cannot produce hair cells, right? Artificial cochlea, that can improve a little bit, but not like normal. Okay? So That's the difficult type hair loss, sensory neural, because it happens due to damage of the cochlea or death of the hair cells of the cochlea. Make sense? So not easy to fix. Some chemicals, like very strong anti-cancer drug or antibiotic can destroy the hair cells. So some medicines or drugs, some chemicals, and another is prolonged exposure to high frequency sound. A person works in a factory that produces very high frequency sound, okay? And you work there like 10 hours, 20 hours every day, that will slowly cause the damage of the hair cells, okay? Sensory neural hair loss. So that is another type of hair loss, okay? Is that enough?
So when
Enough for today?
they said when the eardrum